Hello everybody, today we are moving forward with 8.6, we're on to 8.6 day 2. This section of the notes will kind of be like the last one, where today I'll post the video, give you some practice problems, and then on Monday you will get some more practice problems on it. You can expect a review Tuesday and then a quiz next Wednesday, I believe is how I have it planned out. But anyways, just to get us started, it says to evaluate. Remember, evaluate means you should get a number answer in the end. Log base 2 of negative 8. So again, there's an implied equals x right here. Put it in exponential form. You get 2 to the x power equals negative 8. Now, a common kind of mistake here is say, oh, well, if I want to make this this is a positive 2. If I want to make it negative, I could just say 2 to the negative 3 is negative 8. But remember, 2 to the negative 3, when you do that, a negative exponent goes to the bottom, so it'd be 2 to the third. So in reality, we can't do this. Can't take a log of a negative number. Now, that is, I wrote it right here. Whoops. That's going to kind of come into play when we do more of these examples, because our directions for this first problem says to solve and check for an extraneous solution. Now, this word extraneous, you might remember this. This means like, hey, when I plug it back in, it just doesn't make sense in context of the problem. So we're doing the exact same thing as yesterday, but now we're checking our answers as well and making sure that this portion right here doesn't end up being a negative number when we plug our answer back in. Okay, so this first one says log base 3 of 2 to the x minus 1 equals 4. So the first thing I'm going to do is put this into exponential form. 3 to the 4 equals 2x minus 1. Okay, 3 to the 4th power. This is Perfect card or calculator, whatever you want to do. 81 equals 2x minus 1 plus 1 plus 1. 82 equals 2x. My dog is going to start barking here. I apologize. Mindy, come on. Okay, so now just divide by 2. You get x equals 41. I promise that's not me panting at you here. Mindy, go away. X is 41. Okay, now what we need to do is plug this back in to the original and just make sure that I don't get a negative answer here. So this is log base 3 of 2 times 41 minus 1 equals 4. Log base 3 of 2 times 41 is 82 minus 1, 81 is 4. And again, this answer right here is not negative, so we're good to go. Okay, moving along to the next one. This one we get 5 times the natural log of x plus 3 equals 12. Okay, our first step, we got to get our log, or our natural log in this case, by itself. So I'm going to get rid of this 5. I'm multiplying. How do you get rid of multiplying? Divide, cancel. The natural log of x plus 3 equals 12 over 5. And 12 over 5 equals, plug it in the calculator, 2.4. So I'm going to say it equals 2.4. Now remember, the natural log, this is really log base e of x plus 3 equals 2.4. Put it in exponential form. E to the 2.4 power. E to the 2.4 power equals x plus 3. Okay, now we need to take e to the 2.4 power. I get my calculator up here. Sorry about that. Loading calc. It's loading, I promise. Anyways, what I'm going to do is I'm going to evaluate. I'm going to figure out on my calculator, hey, what's e to the 2.4 power? And then solve for x. So on my calculator, I have e raised to the 2.4 power. I get 11.02. So, oh boy. We now have, this is 11.02 equals x plus 3 minus 3 minus 3. We get x equals 8.02. And again, for the check, now I'm just going to plug 8.02 in for x. So I have the natural log of 8.02 plus 3 equals 2.4. Natural log of 11.02 equals 2.4. And again, I'm not taking the log of a negative number, so this will work out. Okay, next one, I would pay attention to this one. Hint, 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 you will see one like it again, and it's a little, not difficult, just different. Okay, it says log of x plus 2 plus log of x minus 1 equals 1. You might notice and say, well, Mr. Adler, neither of these have bases. Remember, those are log base 10. It's an implied 10, and since they are the same number, I can combine them. This sign is addition, so when I combine them, addition becomes multiplication. Okay, so I'm going to have log base 10 of x plus 2 times x minus 1 equals 1. Put it in exponential power. 10 blue to the green power equals red. So I'm going to say 10. I'll color code it, sorry. Maybe I won't. 10 to the first power equals x plus 2 times x minus 1. Now I need to FOIL out the right-hand side, FOIL the red. So I'm going to go here, 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 here. X squared. Mandy, go away. Minus x plus 2x minus 2. And that's going to equal 10 to the first power is 10. 10 equals, combine like terms in the middle, x squared minus x plus 2x. That should be plus x minus 2. Okay, well, now you might be saying, well, Mr. Adler, now what the heck do I do? Well, let's get everything over to one side, move this over here, and then go from there. So I'm going to minus 10, minus 10, Mindy, minus 10, minus 10. I now have 0 equals x squared plus x minus 12. Mindy, stop it. Sorry, people. Okay, now what I need to do is say, okay, I have a quadratic here, a trinomial that I can factor down, and that is equal to 0. So now let's say, hey, what numbers multiply to negative 12 and add to 1? In other words, factor out what's underlined in black, and we should get 0 equals x plus 4 times x minus 3. Now, two things multiply together to equal 0. Just got to set these equal to 0. X plus 4 equals 0, minus 4 minus 4. X equals negative 4. X minus 3 equals 0. X equals 3. So I have two possible answers here. X equals negative 4 and x equals negative 3. But again, I still need to check here. So let's do negative 4 first. I'm going to plug in negative 4 in my check. So I'm going to say log of negative 4 plus 2. Well, negative 4 plus 2, that's log of negative 2. That does not work. I can't take a log of a negative number. So now let's move on and check x equals 3. When I check x equals 3, okay, I have log of 3 plus 2 plus log of 3 minus 1. 3 plus 2 is log of 5 plus log of 2. Those are both positive numbers that I'm going to underline in the black highlighter. So I can do that. Then my only answer is x equals 3. Again, x equals 4 is not an answer because when I plugged it in, I got a log of a negative number. That's not okay. I cannot take a log of a negative number. Okay, that's the most difficult problem that we have. The next one is actually quite a bit easier. Okay, number 4 is the natural log of 3x minus 10 equals the natural log of x plus 4. Now, you notice I have all this weird writing down here. Ignore that for now. Mandy, shut up. First thing I want to do is say, okay, I have a natural log and a natural log. Well, that's really log base e and log base e. So it's log base e of 3x minus 10 equals log base e of x plus 4. So if you notice here, I have the same log with the same base. I have a log base e and a log base e. So if those are the same, we can do a shortcut. What we're going to do is called saw the logs. Essentially what that means is, hey, just get rid of the logs. So, hey, since these are the same, this is the same, and this is the same, why don't we just say bye, bye? That's 100% legal. You can do it. If the bases are the same, just get rid of them. Saw the logs away. So we get 3x minus 10 equals x plus 4. Basic algebra, minus x, 2x minus 10 equals 4, plus 10, plus 10. 2x equals 14. Divide by 2. X equals 7 for this problem. Now, we still need to do our check because when I plug this back in, I know I canceled off the logs, but it's kind of, think of that as like a shortcut. I still got to check to make sure it makes sense in my original problem. So I got to plug in 7 in both of those. Okay, so I'll move my check up here so that you can actually see. Check. I'm plugging 7 in to the original problem. I notice how messy this is. I apologize. Okay, I'm going to plug 7 into the blue circled original problem. So I get the natural log of 3 times 7 minus 10 equals the natural log of 7 plus 4. Okay, 3 times 7 is 21. Natural log of 21 minus 10, which is the natural log of 11. Good to go there. Equals 7 plus 4 is 11. Again, these are both positive numbers, 11 and 11. So therefore, my answer does exist, and boom. Okay, so again, the only reason we need to check is because we cannot take a log of a negative number. So you just got to plug your answer back in, and if it does equal a negative number, it doesn't work. It's an extraneous solution. Okay, that's all I have for you today. If you have any questions,